Hi, I'm Tobin Booth. This is Tech Talk Tuesday. Today we're here to talk about this sample underground aluminum conductor. And what you're looking at here are two current carrying conductors, an insulated ground with a protective overcoating, inside a metallic armor and a protective overcoating. And this entire assembly is what we use commonly for direct burial underground conductors on large-scale solar array fields. And the number one reason we use an assembly like this is for cost savings. The aluminum underground conductors like this are about a third the cost of their copper equivalent. And every decision we make generally comes back to that cost savings and why we use this specific conductor. Now, in size versus weight, yes, aluminum conductors are larger than their copper equivalents. However, the weight is about half. So this entire assembly is about half the weight of a copper equivalent if a copper were to be used in lieu of this aluminum alternative. Now, when we go and cut a trench out in an open array field and lay this assembly in, we lay this in as a single conductor, as a single assembly unit, instead of potentially gluing together underground conduit, then pulling various size cables through. This is laid down in one complete assembly, and there's an amazing amount of time savings represented in that simplified process. Now let's look at the other end of this conductor. As you can see here, we stripped away the insulation, and you can see the bare aluminum conductors being exposed. The same with the ground. There's a reason that the ground is insulated, and I want to talk about that now. If the ground is going to be terminated within 18 inches or less of the surface of the soil, the ground is required by the National Electric Code to be insulated. And the reason for that is because the condensation can occur between the termination point and the ground, creating corrosion and reduced electrical safety from the ground. So the ground is insulated, and that's very important. You don't necessarily see that if you were to pull a copper underground conductor. That's extremely important for choosing the proper aluminum assembly for underground applications. This is the conduit body that's used to properly seal and terminate this assembly to a combiner box or other enclosure. So when you come out of the ground and into a combiner box, this is the proper assembly to use. This conduit body seals against water intrusion, rodent, dirt, dust intrusion, and it provides the proper grounding point for protecting this assembly. And finally, let's talk about terminations. We did mention that the ground has to be insulated for using an aluminum conductor. That's essentially the message I wanted to convey here. Terminations are extremely important when you're using an aluminum conductor, and it's simply because the thermal coefficient of expansion for aluminum is about double or more of its copper equivalent, and that thermal expansion over time can cause fasteners to loosen. So you have to use the proper terminations to terminate this conductor, and you have to have a rigorous operations and maintenance schedule to maintain this conductor and the electrical system over time. These are the three major points that we consider when using underground aluminum conductors. Hope this was useful to you. We'll look forward to seeing you next time.